So we'll discuss diform tool in this session. So here we'll look into the diform tooling different options, how you can configure like the sheet surface, the bound plane and the placement, and how you can use your external files for placement, that also we'll look into. So for understanding this, we'll take a simple sheet with size 50 by 50 and you have the typical thickness 0.1 and even you can go for 0.2. So directly from the form tool you can get here diform and you can get reference and you can select your reference part whichever you need to define. So this is the form tool which you have. Directly open this. After opening this, you will get the preview of this part. So you need to place this. I'll select this as the reference, which will be placed with respect to this. As this is the round part, I will set the constant for datum plane, this datum with this datum, and this datum with this datum, and go for OK. You can see the preview of placement directly here, and you can go for OK. And here you have to select the bounded plane. This is the reference bounded plane and the sheet surface is this, and you can see the preview. Go for OK. So this die form will be created over your sheet, and in this way you can directly configure any existing die tool for using as a forming tool through your sheet. Next we'll look into the transitional band, which is very important because in case of your transitional band over the typical areas you can restrict the bending and you can define a particular zone as your transition band zone. In this particular band zone your bend will not be performed. So how to define the transitional band and peripheral controls I will show you. We'll close this particular session, we'll erase from the memory, and from your exercise folder you can directly get your transition band option, and this is the part which you have. Directly you can open the transition band part, and when you go for the transition band, what you have to do is, this is the sheet which you have and we have selected the rule. Any particular degrees rule you can select, 18 maybe, and when you go to transition here, I'll just remove the sketch. This was the initial output which you have. I need to restrict a particular area for my deformations, that is the bending. So I'll go to edit definition and I'll go to transition and I'll go to add transition and I'll go to sketch and I'll select this particular surface. My transitional areas I'll be defining. This will be my transition area 1 and this will be transition area 2. In between I don't require any bending. So you can see when you select, this particular area will be restricted for bending, and you can see this is the best case for your transitional bend. You can operate this. But here if you go for any curved profile, let us say I am interested to have a curved profile instead of a straight line, what is the message you are getting, that also you should must understand. So you are not able to assess any curved profile with respect to transitional band. So you have to have a straight line as your transitional band reference always. Next we will look into the strip layout tool, how you can create the strip layout from your blank. That I will show because this is very important from the manufacturing point of view. I will not focus much about your manufacturing, how to define the maximum number of strips from your blank, that I will show how to maximize the process. That will be my primary focus. So you can see the manufacturing sheet metal, you can have a provision for creating the sheet metal blanks. So let us understand this in brief. So for understanding this, I will open and I will show the part which I will be considering for manufacturing strip layout. From your exercise folder you can get mfg underscore strip underscore layout. So this is the part which already we have discussed before for creating the blank. So I'll just hide this information. This is the part which we are looking at. So how to create the strip layout, the maximum number of strips, how we can extract from your blank, that I will demonstrate. I'll just close this. I'll go to new, manufacturing and sheet metal and give a name as per requirement and go for OK. Here you have to switch the unit to mm because your base unit is mm. The part which I have shown you, the thickness which we have is 0.25 for that part, and this length I will select 1000 by 1000 and 0.25. And once you select this, you can go to the automation. Once you go to automation, here you can load your part file which I have shown from the manufacturing strip layout. Once you select it, it will automatically load. And here you have couple of options which I will show you in brief. The order and done. Let us say I am ordering from 1000 and 1000 size 100 strips, and I can see the preview. It is only 91 is able to do it, but most of the space we have not optimized, and these are the different scraps you can see out of this. So how to optimize this? So out of this 1000 by 1000, only 91 I can expect, but this is not correct. So how to set this? So workpiece size also you can see 1000 by 1000 and thickness 0.25, and border size you can give from this corner, let us say 0.5 left, 0.5, 0.5 top, and 0.5 your right. You can see the preview, and you can have this border offset shown here from other side. I'll go to the default, and here you can give the offset from this boundaries also. I am giving 1 from outer, so outer not required here, so inner I'll give 1, and you can see the preview. Here the allotted distance will be set. Outer also you can provide if you need this. So this distance you can from the inner, from the outer you can control, and you can see now 90 you can expect. But if you optimize this, you have a clustering, and here as you saw 1 by 1 already have given, so 999 is the effective size which you have in the length and width. And now if you go to the preview, now you can see 100 you can expect, but still you have lots of open space available. So here you can go for more orders. So 111 is possible here, and this you can always check for the alternative numbers. So 110 is possible, so here you can expect another one. And also you can control the overall orientation here. If you go to this particular case here, you can see the rotation angle, and rotation angle you can see any, and you can go to the step. I can have 180. Based on that you can see the different strip position. 107 is possible here. Just like that you can have all the controls, and you can only increase this 90 90 90. So maybe a particular values you can set. So the values would be 0 and 180, because even though this is equivalent of that, you can go for 0 only, and you can see this, and finally will be done, and you can go for the save. Then you will be entering into the manufacturing database for creating the machining operation. So our agenda is not to go to manufacturing, only to show you how you can create this, and after that you can directly save these informations either in the form of IGS or DXF. So whatever the format you like, you can select this either in the IGS or any other format which you need to go for, maybe drawing, maybe you can go for the IGS or maybe DXF. So just you save it and you can use this during your drawing creation. And this particular methods you can directly use for rapidly saving your scrap, so that you can optimize the overall process. Thank you.